Some of the new things coming in versions of SMS 13.0. Some of these are available in 13.0.8, which is mostly available to all of the Corps of Engineers. Some of these, like the one I'm talking about today, is actually not available in 13.08, but it will be available in 13.09 and later, as soon as they're approved and on the ACIT app portal. But everybody else that's here that is a non-USACE employee should be able to get to 13.0.9, which is the current release of SMS, and be able to get to this. So what we're going to be talking about today is the dredge placement operations with CMS and some of the newer advancements that we've worked on a couple of years ago, but they've never really made it into a nicely usable system or available in the SMS. So we developed some screens to enable it and to make it available, and we're going to go over some of that today. So this is basically all there is. There are two screens that you'll be working with, one for dredge operations or cutting of material, and then another one to be able to place that material into up to 3 different placement areas per dredge operation. A lot of times we'll be working with our district offices, and they'll have a couple of different alternatives that they want to work on, and this will help us do that. And what this particular one does is we can plan a simulation for a set amount of time, and during that simulation may have been a point in time where the channel or some area was dredged and that material was placed in another location. In the past, what we've had to do is to actually run up until the point of that dredge, run CMS, and then we'd have to change our grid a little bit and then restart CMS after the dredge has already run. And so this will allow us to do it a little bit more inline and not have to do any starting and stopping. We will have another addition in 13.1 that's basically allowing the user to do multiple sediment management alternatives from the get-go. So not that would happen after the run has started, but different alternatives that the user could work on from scratch. So anyway, just to go ahead and get into this a little bit more, just a little bit of information. This is a demonstration. It's not a real area. Forgive, some of the assumptions that we're making here. We're just doing this as a proof of concept. This was one of the ones that we did for our multiple sediment grain sizes, and so just going from that. So the first thing what we're going to do, and just to start off, I'm going to do this every day this week. We're going to actually give a presentation of what we're going to be doing, and then we're going to move into a demo. And it's not really enough time to do a true hands-on with interaction with the attendees, but hopefully it's good enough to get the information across to where you can do this on your own when you get back to the office. We have all the files together for you guys. That is available on the SERP website, and I'll just switch over real quick and show you that. So on the SERP website, we have a page here for this particular webinar. We have links to the SMS, and here's a link for USACE employees and one for non, and also the version of CMS that we're going to be working with this. I'll show you how to grab that and get SMS to actually use that version instead of the one that comes with it. The other files are available lower down. So on day one, we have a link to the presentation that I'm going to show you here, and then also to the actual data. And so you would just grab all that, and then you should be ready to follow along with me. And I will be recording all of these webinars this week, and so you'll have access to that later on, so you can follow a little bit easier as well. So when you're back to the webinar. So the first thing that we would do is to pull in a simulation that we've already done. So as I may have mentioned in the announcement, this is an advanced course, and so we did a basic webinar earlier this summer in late spring, and so that covered how to generate the actual grids and bottom friction and all that information, and so we're not going to go over that again, but what we're doing here is starting up where that left off. And so I've loaded a case here, I've got everything saved, I have the SMS project file, I'll load that into SMS, and then I will have my grid. So this grid is just a basic planar beach, basically, from certain depths up to the shoreline. And the first thing that we'll need to do to plan for this or schedule this dredge event that's going to happen is we need to tell SMS where those areas are. And the first thing that we would do is go to the map module, and we will, as this says, create a coverage in the map module, and it doesn't have to be any particular type. The default is area property, and since that's the default, it works perfectly fine. Just use that. You'll need two different coverages, one for placement, one for dredge. And you would just define arcs for the area that you want to use to actually cut the material out and to place the material. And so for this example, I've got a channel here where I've defined, so this is feature arcs that are connected back to itself, and so it actually turns into a feature polygon, and then we can assign some information in just a few minutes. And I did the same thing for the placement. Okay, so each one of these is showing up even though they're in different coverages. And just as another note, you can, if this was already provided from some of your coworkers in ArcGIS, you can pull in shapefiles and work with them just as easily. The only thing is you need to make sure that they are connected polygons and built as far as the SMS is concerned, build polygons. I'll show this in just a few minutes when I get into the demo. So once those zones are created, what we're going to do is actually make two different data sets that are going to contain certain values representative of our dredge area and our fill areas. So what we're going to do here is in the data calculator. So that's under, on the main pull-down menus under data, dataset toolbox, and one of those options is data calculator. For this dredge operation, what we're going to do is just, well, actually for both of these, set the default value for each of them to -999. And that basically says everywhere else except for where we specify, just ignore. And so what you would do is go through and create two of these. One of these for the dredge operation, so I've got -999 in the calculator. I've got dredge as the name of the data set. I would then just hit compute and then go through the same process and create another one for placement. And you can name them whatever you want, it doesn't matter, but this is what we kind of go by. And then as specified here, later steps, we're going to be modifying these values. So to modify those values, what we need to do is first select the cells that we want to change. And the easiest way, you can go through and pick them out in this region one by one if you want. But another way to do that is use some capabilities from the SMS to select within a polygon. And so what we would do is go over to the map module, select the polygon, and in this case I've got the dredge polygon selected. Then under the pull down menus you'd have feature objects and then select and delete data. And once you do that, you'll come up with this dialog here, and then you would just tell it to select inside the polygon from the quad tree. You might have to select cells. There may be some other things here, but just make sure you do select inside quad tree cells, and then make sure that if you have more than one quad tree or more than one project loaded, just make sure it's going to be operating on the right one. Select that. And then once those are done, you hit OK. It goes in and selects the cells that are completely within the polygon. And that's a little bit problematic because sometimes we may want some other cells, and you'll just have to add those cells manually after the fact. So what we'll do right now, we have a selection that is selected, and then up under the pull down menus there's another line. One of the values there next to the letter S, which stands for scalar dataset, can be edited, and we would just enter a value into that block that we want to set as the maximum depth for all of the cells that we're going to dredge down to. And in this case we're going to dredge down to 6 meters. Just picked a number that tends to work pretty well, and so that's what we're going to do. So for every cell that's selected, we're going to give those values, those cells, the value 6. It's a little bit different for the placement zone. All it really needs to know is yes, place here, or no, don't place here. And so for that, we're just going to edit we would reproduce this for the placement zone and just change the values to 1 instead of -999. So that's all it is. In later versions of SMS, probably 13.1 or a little bit after, we're going to be modifying this a little bit to where it's not operating on entire data sets at the same time, but it's only within the polygons. It'll be a little bit easier to define. But for right now, we're kind of stuck with this, this method until we can get that working. So anyway, moving on to the next step. So in this case, we've got the 2 data sets, one for dredge, one for placement. We just want to look and make sure that we have all the cells specified as we need to. So we'd go over into the data tree and select the dredge data set, and then these values would kind of show up. I've got the colors just set so that I can see exactly what's selected and what's going on. And so in this case, we see the cells within this zone, and they're given a depth that's higher than our range here, but it's 6. And in the placement, do the same thing. You select the placement data set in the data tree, and it shows this one over here, and it shows within that zone all the values are approximately 1. And it doesn't matter, it could be 6, it could be anything as long as it's not -999 or 0 or less, actually. So moving on, like I said, if you need to add additional cells to these zones from the automatic selection, you would do that before you start saving out your files. So when you're done, what you would see in your data tree, we've got the grid, we've got the Z data set, we've got a dredge and placement for the 2 things we just set up. We also have our sediment transport grain sizes with the D50. We also have a Manning's N, which is our bottom friction data set. We showed how to set these 2 up in the previous workshop webinar. So if you need to know how to do that, then we have those recorded and you can go back and listen to that and work on that. The other thing that I have here is we have our area property. We have, I just renamed that map coverage that I created as DM zones or dredge module zones. And so that one coverage has both the dredge and placement polygons. And then we have, of course, our annotation layer that has the north arrow. And then we have our simulation down here ready to go. And so it's basically got our grid with all of this information and our boundary conditions. And in this case, we don't have any land or water cells differences, so everything's water. We don't have an activity classification. So if you need them, all of these files are either in the Start folder, or we have a StartFiles, which is where we started from. We also have an Other Needed Files that has some of these others, and it's not pulling up for whatever reason. There we go. So some of these others, if you need these extra data sets and you don't remember how to create them. And then I've saved all the results into this final files if you need to come in later and pick up. So let's move this out of the way and keep going along. So for the Dredge module, what you'll be doing is you right-click the simulation folder. And normally there's a button there for model control. Now in 1309 and later, there's also an option there for Dredge module setup. You would click that, and then it brings up a dialog with two tabs. And one of them is the Dredge definition tab, one's the placement definition. And under Dredge definition, you can actually turn it on. Otherwise, it just will not write out anything. You don't have the ability to save anything. So you would enable that by placing a check mark, and then you would select the Dredge dataset that we created. There are a few different options there to choose from for the Dredge method. In this case, as an example, we're going to choose specified cell. So basically, it starts at a certain cell in the grid, and then it moves away from that cell as time progresses in the simulation. We have a dredge rate that we're defining, which in our case is 10,000 meters cubed per day. We have a trigger depth, which is basically 6 meters deep. So once it gets to 6 meters, it stops dredging at those cells. And then we have a distribution. So in this module, we have the ability to distribute among multiple placement areas. And so we have options here for give a certain percent to each one. There's another one that basically says uniform, so it's everything. And it just places in every cell as much as it can for the placement zones. The actual percentages are going to be defined in the placement tab. So then we go over to the placement tab, and we'll make sure that we can define placement area 1. You'll select the data set where that placement, where we specify those values. We're going to say for the placement method, we're starting at a certain cell, and then we are placing material outward from that cell. So as the dredge would move, it's not exactly how a dredge would move, but it's as close as we can get in this automated fashion. And we've got a value there. We've got distribution percentage, and so since we're only using one placement, we have to specify 100%. So if you had 3 zones, you could have one of them set up to get 50% of the material and the other 2 to get 25% each. Something like that, you can work with that. And then the limits, it shows that the thickness is 1.1 meters. So it'll place 1.1 meters in every cell and then move on to the next cell. And so you can play around with these values based on what you would normally see in your situation. Then you click OK when you're done. And then you could set these files, save them, and then start SMS. So one of the other things that we're going to be doing as far as this particular example, some model control settings that we're setting up. We're running for 550 hours. We're going to have a hydrodynamic ramp of 2 days. We're going to set up a hot start to go to write out every 48 hours. We select our Manning's in data set for the bottom friction. We're going to have output every hour for 720 hours, even though we're only running 550. That's just the default. And then we're going to output some more information. So for each one of these types, then you select all of the sub buttons. So I'll show this in a minute. Then under the Sediment Transport tab for model control, we're going to be using a transport grain size of 0.2 millimeters. And then we're going to be using multiple grain sizes. We're using a simplified way of specifying this. Some of this will be covered in a later webinar this week under multiple sediment grain sizes. I guess that is day 3, so Wednesday. So some of this will be covered then, but I wanted to go ahead and cover this because that's what we used for this particular example. So we're using 3 grain sizes of 0.2 millimeters, 1 millimeter, and 4 millimeters. Standard deviation. We have our D50 data set selected, 5 bed layers with a mixing layer of 0.2 meters, and then the rest of the layers at 0.8 meters. Once we have that, we save, export, and launch. So there's one button here, and it'll save everything out, it'll write the files, and then it starts the run, and then we can come over here and click CMS flow in the run queue, and then we show, we can see this progressing. And so once it's done, we can hit, once it's done, it'll have a button. This changes from abort to load solution, and we can either load that right then, or we can close this and then load it manually. And so what we're going to be doing is using the latest executable. This is 5.1.10. It's actually 5.1.11. We had found a couple of issues that we resolved. And so you go to this location and pull down the newest CMS version. And then to get SMS to use that, you would go under Edit Preferences, File Location, find CMS Flow in the list, and then go to actually where the file is located, where you save the file after you've downloaded it from here. So just to show that website real quick, as far as the wiki, you would come to the SERP wiki. We have a documentation portal over here. And then one of those options is, this is the documentation portal. It's got a lot of information here, but one on the right-hand side says CMS releases, and then that brings you here. So we have all of the pretty much major versions, the latest update for each of the major versions that we have. And right now we're at 5.1, update 11. We have links to the files that you'll need, and then you can also see kind of what has been added over time if you want to see that. So you would download that file and then link that in with SMS so it would run. And then once you're done, you bring in the results, and then you can visualize what exactly happened. And so this is the very last time step after, I think it's 22 days. So it pulled material from here, starting at this upper right-hand corner, and it worked its way down. And as it's taking the information from here, or the material from here, it's actually placing, starting at this location and working itself out this way, away from the cell. And so you can actually visualize that and see what it looks like, and we'll get into that and show it here just in a second. I know I went over that really quick and it was a little bit haphazard. Are there any quick questions? If there are, just type them in the chat. Everybody's muted right now, so it'd be hard to unmute and do all that. But if there are any questions, please write them in the chat, and either myself or Honghai Lee, who's also in this, will respond to those as they come in. So just to move on, I'm going to go into the demo.